using Codex to write code right now, or you're figuring out how to build an AI-powered programming workflow, this video is for you. Over the past few months, I went through a complete detour. I built a cross-platform multi-agent framework, used two popular tools in the space, and distilled everything I learned from the mistakes into what is now VibeRig. By the end of this video, you'll understand where multi-agent parallel development breaks down, why shared context doesn't equal better quality, and what an AI workflow that's actually observable by humans looks like. All right, let's get into it. Earlier this year, I built a tool called Agentic. It could schedule over a dozen AI agents to write code in parallel, supporting 4 platforms: Claude, Gemini, OpenCode, and Codex. Each agent had its own Git branch and its own terminal window, running fully independently. About 2 months later, I shut it down. No more maintenance, no more updates. I didn't shut it down because it failed to do what I wanted. I shut it down because I realized what I wanted was wrong from the start. The story starts the day Claude Code launched team mode. At the time, I was using Claude Code to write code, and it felt pretty good overall. But there was one thing that constantly bothered me. When Claude Code was handling complex tasks, I had absolutely no visibility into what it was actually doing. It would hand you a result, but the process in between was a black box. What it was thinking, what decisions it made, what problems it ran into, and how it solved them, none of that was visible to you. Then team mode came out, letting you run multiple agents. But for me, the observability problem was still unsolved. And with multiple agents running at once, you had even less idea what each one was doing. So I thought, why not build this layer myself? A CLI tool that puts every agent's state somewhere I can see it, so I always know what task each agent is working on and how far along it is. The other reason was that I wasn't using just one tool. Gemini sometimes had stronger search capabilities, OpenCode produced better output on certain types of tasks, and Codex was very stable for code execution. I wanted a unified scheduling layer that could route work to the best fit AI based on task type. That was the original design motivation behind Agentic: observability plus cross-platform scheduling. Let me briefly walk through the architecture so you can understand the contrast later. The core of Agentic was a role plus worker model. A role is a character definition. You could define a go-back-and role with its own system prompt, toolstat, and work boundaries. You could also define QA tester, rules writer, or front-end architect. Role definitions were reusable across platforms. The same definition could run on Claude, Gemini, or Codex. A worker is a routing instance. You assign a task to a role, it opens a new Git worktree, opens an independent terminal window, loads the role system prompt, and gets to work. In theory, you could run 5 or 10 workers at once, handling 5 or 10 requirements in parallel. I even built a role hub where you could pull other people's role packages from GitHub, like a plugin marketplace. The moment it fired up, it felt incredible. Multiple terminal windows all moving at once, every one of them writing code. It felt like running an AI factory. Agentic didn't go down because of one catastrophic bug. It was a slow accumulation of problems that eventually made me realize the direction itself was flawed. Problem 1. The main agent's context kept growing until it broke down. Agentic had a master agent responsible for scheduling. As tasks got more complex, it needed to track the state of every worker, every task's progress, and all the context. That master agent's conversation context kept ballooning, and eventually things started going wrong. It would forget what it said earlier or start contradicting previous decisions. A bigger context isn't better, it's more chaotic. Problem 2. Terminal-based communication had too many limitations. Agentic passed information between the master agent and workers through terminal messages. This wasn't a natively supported communication method, it was a layer I built myself. So edge cases kept cropping up. Sometimes a message would be sent, but the worker wouldn't receive it. Sometimes things would just stall with no response. Sometimes the two sides would have mismatched state. These issues were scattered and a nightmare to debug. Problem 3. Worktrees got messy too easily. Each worker had its own Git worktree, isolated in theory, but in practice, managing worktree state was far more complicated than I'd imagined. Sometimes a worker would crash and the worktree would just sit there. Next time, you wouldn't know whether to clean it up or not. Sometimes two workers' worktrees both depended on the same file, and one side would change it without the other knowing. Managing the worktrees themselves became extra overhead. After shutting down Agentic, I didn't immediately build something new. Instead, I used two existing tools to see how others were solving these problems. The first was GSD. Get shit. Its core approach is meta-prompting plus context engineering. It genuinely solved one of my pain points. It enabled context sharing between agents. I used it for a while and found that the shared context direction was right. But having more context doesn't automatically mean better quality. GSD gave the AI more information, but the quality of the code it wrote didn't improve as a result. Information isn't the bottleneck. Judgment is. The second was Superpowers. Superpowers' brainstorming feature was well designed. It would decompose requirements very granularly and generate comprehensive planning documents. I used it for a while, but one problem persistently bothered me. Its output was too hard for a human to read. The AI would generate enormous volumes of documents and analysis in complex formats with very high information density. But as a human trying to review whether a requirement was actually complete, I had to sift through all that output every single time. It was exhausting. Brainstorming was great, review was painful. I kept feeling like this stuff was written for the AI to read, not for a person. These two attempts helped me clarify something. What I actually needed wasn't better AI collaboration. It was a workflow that a human could directly understand and directly operate. After months of iteration, I started to see things clearly. First, the multi-agent collaboration I needed wasn't mine to build. Agentic used terminal communication to coordinate multiple agents, essentially a fragile simulation of agent collaboration. But Codex's own multi-agent mode already does this, and it does it far better than I ever could. Inside Codex, sub-agents can share complete conversation context. Within the same session, one agent can directly reference what another agent just said. No terminal message passing, no stalling, no dropped messages, no mismatched state. Codex has made specialized optimizations for inter-agent communication. I had no reason to re-implement a worse version. I should be building on top of that capability, not around it. Second, context can't be maintained through conversation. It has to live in files. GSD's direction was to give the AI more context. But I found that the bigger the context, the more the AI struggled, not the reverse. The real solution isn't managing a larger context. It's not depending on conversational context at all. Store everything important as files. Let the AI read them whenever needed, and every read is fresh and accurate. Third, output needs to be directly readable by humans, not just by AIs. Superpowers' problem made me realize the right measure of a good AI workflow isn't how much information the AI processed. It's whether a human can understand the current state, task progress, and review results within 5 seconds. If a person can't understand it, the workflow is broken. These 3 conclusions are the design starting points for VibeRig. Let me walk through VibeRig's 7 core design decisions and what problem each one solves from my earlier experience. 1. All information lives in files, with zero dependency on conversational context. One of Agentic's problems was that task information and execution history all lived in the terminal. Once a conversation got long, it was impossible to find anything, and different terminal sessions were completely siloed. VibeRig is the opposite. Before any requirement is executed, it generates a set of local documents: requirement background, architectural decision records, acceptance criteria, all independent markdown files stored in .viberigs/requirements. What does that mean? It means the AI can always directly read these files to restore context without relying on a long conversation history. Even if you open a brand new Codex session, as long as these files exist, the AI knows what this requirement needs to do and how to verify it. Zero context dependency. 2. Use linear to manage tasks, not something buried inside the tool. Agent team state lived in .agentteam/task YAML files. Fine for me as the developer, but if you want to collaborate with a team or come back to it after a few days, those YAML files are a terrible experience. VibeRig maps each requirement's acceptance criteria directly to linear issues. Every task status, in progress, in review, done, shows up on the linear board in real time. Now, when I check on the AI's progress, it looks exactly like checking a normal project. Open linear, and at a glance, I know what's in progress, what's blocked, and what's done. Human-readable state, not YAML files. 3. Goal mode plus agent soft loop. The agent finds the problems itself before it tells you. Codex recently added a goal mode where you set a goal and the agent iterates continuously until it's achieved. VibeRig's agent SOP is an execution protocol designed around this same idea. It works as a complete loop. The agent first analyzes the task scope and decides whether tests are needed, writes the tests, has a sub-agent QA those tests, implements the code, self-verifies by running it, then does a final QA pass, while in parallel running code review, security audit, and test coverage checks. If any step fails, it automatically loops back to the right stage. If test QA fails, back to the test phase. If verification fails, back to implementation. The default is a maximum of 3 rounds. If the same failure repeats twice without converging, it stops and proactively tells you exactly where it's stuck and what decision it needs from you. This solves a very practical problem. Before, the AI would write code and tell you, done, but there's still a problem. To react, find it and fix it yourself. Now the agent SOP loop means the agent finds and fixes problems on its own before it tells you it's done. What you see is a result that's already gone through multiple rounds of self-validation, not a first-pass draft. 4. SkillOS self-zoning. Learn only from accepted work, not from the process. SkillOS has been a trending direction lately, letting AI systems automatically accumulate and evolve their own skill libraries through use, getting smarter over time. VibeRig implements a more conservative, more precise version called SkillOS Lite. There's only one core principle: learn only from accepted work. Each time you accept a requirement, SkillOS Lite analyzes the evidence from the entire process: the requirements document, code changes, test results, your acceptance decision, and judges whether there's a pattern worth preserving. Its output is a proposal. Insert a new skill. Update an existing skill. Deprecate, retire an outdated skill. Or, no, nothing worth learning this time. The proposal must be conferred by you before it's formally written to the skill library via Skill Builder. Why not auto-learn? The problem with many self-learning frameworks is too much noise. A technique that happened to work once, a temporary fix, a snippet that only applies to a specific scenario. All of it can get learned. When the AI encounters a similar problem later, it gets steered wrong by these Walfier, re-ask count as drawing it plain. The proposal must be confirmed by you before it's formally written to the skill library via Skill Builder. Why not auto-learn? The problem with many self-learning frameworks is too much noise. A technique that happened to work once, a temporary fix, a snippet that only applies to a specific scenario. All of it can get learned. When the AI encounters a similar problem later, it gets steered wrong by these false experiences. SkillOS Lite is designed so that only work that's been fully validated and explicitly accepted by you is eligible to contribute. Every entry in the skill library has evidence behind it. The more you use it, the sharper it gets, not the noisier. 6. Multi-layer sub-agent cross-validation. After a task is complete, it doesn't go straight to a PR. It goes through 3 independent sub-agent checks. Code_review handles logic and readability. Security_auditor specifically looks for vulnerabilities. Test_engineer checks test coverage. These 3 run concurrently. If any one of them finds a critical issue, delivery is blocked. The key isn't how many agents there are. It's that their perspectives are completely independent. The agent that wrote the code and the agent reviewing it are not the same. That's what makes review effective, not self-checking. 7. Inject prompts at initialization to make AI responses observable by humans. This is a design decision most people won't notice, but I think it's crucial. When VB initializes a project, it injects a block of prompts into agents that constrains the AI's response format throughout the entire project. The rules work like this. Each response can only use one primary format. If the content is a process or state, use a mermaid flowchart. If it's a multi-dimensional comparison, use a table. If it's execution steps, use a checklist. If it's reasoning or explanation, use the what, why, how, when for cell structure. If none of those fit, one sentence. No prose summary appended after the format. Let me show you a real comparison. Same question. Should we use REST or GraphQL? Without the injected prompts, the AI typically answers like this. Great question. Let me walk through the key differences. REST is an architectural style based on HTTP, and its advantages include GraphQL, developed by Facebook, is overall, both have their merits, and I'd recommend evaluating your specific use case. You read all of that, and you still don't have a decision. With VibeRig's injected prompts, the same question gets answered like this. What? Use REST? Why? Under 10 endpoints. Team already knows REST? No overfetches. How? Add endpoints following existing root conventions? No new depths. When? Revisit GraphQL when client customization grows or endpoints greater than 20. 4 lines. The conclusion is in line 1, the reason in line 2, how to implement in line 3, when to reconsider in line 4. 5 seconds to read, and you know exactly how to decide. That's observability. Not how much information the AI processed, but whether a human can extract the basis for a decision directly from the output, without having to distill or summarize it themselves. You might ask, Agent Team supported 4 platforms. VibeRig only does Codex. Isn't that a step backward? No, it's a deliberate choice. Multi-platform support sounds appealing, but the cost is this. You're always limited to the lowest common denominator, the smallest set of features that all platforms can support. You can't use Codex's deep MCP integration, you can't use native sub-agent context sharing, you can't use any of Codex's built-in tools. And maintaining cross-platform compatibility is itself a massive burden. Every platform's API is changing. Every platform has different conventions for tool calls. Choosing to build only a Codex plugin means I can put all my energy into using one platform to its full potential. Direct linear MCP calls, direct GitHub bot integration, agents sharing complete context within the same session. These capabilities simply aren't achievable in a multi-platform framework. It's not that I can't build multi-platform. It's that building multi-platform means doing every platform badly. All right, after all that, VibeRig is simple to install. Codex plugin marketplace, add Jason Lee 12138/Codex marketplace, the RAF main Codex plugin -rig at Jason Lee 2 commands. Restart Codex after installing, and you're good to go. You need to have Codex and the linear plugin set up first. The project is open source. Link is in the description. Open an issue if you run into problems. Contributions are welcome. One last thing I want to say. I don't regret building Agent Team. Those 2 months helped me genuinely understand what I'm actually after when it comes to AI-assisted programming. I don't need more agents running at the same time. What I need is that every delivery is a result I can trust and use. VibeRig is my current answer to that. If you're also working through AI programming workflows, drop a comment telling me what problems you're running into. I read and reply to every single one. If you found this useful, hit the like button so more people can find it. See you next time.